Good morning, everyone. My name is Felienne Hermans. I'm a full professor at the Vrije Universiteit Amsterdam, and we're going to talk about software today. So if you want to know about software, of course, you can listen to developers, but maybe it's better to listen to artists. For example, my favorite Dutch folk singer, Sophie Straat. She says that there's no longer a need to go to Amsterdam because everything is already on Instagram. And I think this really beautifully captures that the world has changed because of software. Right? Little stores where no one would go are now crowded with people because it was on TikTok or Instagram. Someone's basement or attic is now a hotel on Airbnb. The whole world is changed because of software. And I was a bit worried that this would be a bit too much Amsterdam-y, but I was sort of happy that when I arrived in Australia a week ago, when I went to the airport, I figured out that there was no longer a taxi stand in Melbourne Airport. There was an Uber stand in Melbourne Airport. And I thought, okay, so it's also happening here, right? Also, Australia is changing because software is impacting how we travel, how we communicate, where we go, to a large extent. And I think it's really important that everyone can participate in this conversation, right? Imagine you all are sick of this. You don't want an Uber stand. You want a good old normal taxi stand. This requires some programming knowledge. You say, okay, we will make our own Brisbane app, Brisbane Taxi or Melbourne Taxi. But it's not so easy to create this. It's not so easy even to come up with the idea that this would be a possibility. And because the world is changing because of software so much, I think it's very, very important that everyone at least has a little bit of programming skills so they can participate in this conversation and change the world through their own software. However, some people, of course, now, like Erik Meijer, for example, in one of the talks you can see today, says, oh, we don't need programming skills anymore because we can just use GPT, right? Why would people still need programming skills in the age of GPT? This doesn't make sense. So initially, when I started to hear this sort of objection against teaching programming skills in the broad sense, I thought, I don't care, right? This is such a silly opinion. I'm not even going to engage with this silliness because of course people still want to have programming skills in GPT. But the problem is if us programmers are going to say that you don't need to know programming because there's GPT, very soon regular people, the non-software people, will also start saying that programming knowledge isn't necessary, further limiting the number of people that can do programming. So that just is not great, right? If we start this, other people will adopt this opinion as well. So I'm going to present a few arguments why we still need programming skills in the age of GPT. Question, who in the audience has ever ran a marathon? Yeah, good for you. So why though? Why would you run a marathon? There's cars. This doesn't make any sense. Cars, bikes, planes, trams, buses, blips, right? Why would you run a marathon? This doesn't make sense. Technology can easily solve the problem of going 42K for you. Why, right? Why would you do this? Because a marathon is not about finishing, right? This is not the marathon. This is the marathon where you're like, oh, I'm almost dead. 30K, oh, I hate this, right? That is what the marathon is all about. Like doing a marathon is, once you do 3 hours, 57 minutes in a marathon, and then for the rest of your life you bring this up in the supermarket and a birthday party at a keynote conference. This is why you do a marathon, because you want to do the distance, not because you really just want to travel it, you want to do it, right? This is why you want to do a marathon. This is also why it's important for people to do programming, that afterwards they say, wow, I have done some programming, specifically if they're non-programmers. That pride that I see if I help people learn a little bit of programming, they're like, oh, wow, I didn't know I could do this. That is what matters here. So don't let the machines kill our pleasure, right? That if you enjoy doing something, we shouldn't outsource this to machines, even if they exist. There's another argument, though, that's maybe a little bit more subtle, and that's like, what is even the goal of teaching people programming? Why are we doing this? I don't think it's so clear, actually, for many people why we're interested in teaching kids programming. I think a lot of people think that programming education is you take a child that knows what programming is and you turn them into a child that knows programming. That makes sense, right? So I want to know, I know what programming is, I want to do it, and now I know it. But there's actually a way more interesting part of the population, that a bigger part also, that doesn't even know what programming is. And I think my goal in teaching people programming is turning people that don't know what programming is into people that know what programming is. And I understand this sounds very abstract. Maybe you're now like, okay, 5 minutes in and she has lost me. So I will make this a little bit more concrete with a metaphor. Who here in the audience has never ever made their own clothes? Raise your hands if you've never made your own clothes. This is a lot of people, yes? So why not? Have you ever went to a shop and you're like, oh, I want to have a blue sweater. And then you go to the shop and they don't have a blue sweater. You go to another shop, they don't have the sweater that you want. You're like, okay, I'll buy a green sweater. So you could make clothes. You know that this is a thing that exists. People do this, but you don't do it. So there's so many people that have never ever made their own clothes. And this isn't just because you've never done it. It's because you've never even considered this is a thing you could do, right? You didn't go to 3 shops and then after the third you said, I will make my own sweater. It didn't occur to you that that was a possibility. This is how so many people feel about programming. They use apps on their phone and they're like, oh, I don't like the way this app works. But they don't say, I will make my own, I will change this. Not because they consider it and they reject it, but they don't even consider that changing a program or making their own program is a thing they could do. And that's where the problem lies, that we want to explain to people with a little bit of education what programming is. So we really don't even know, you all don't know what making clothing means in the same way that many people don't know what programming means. And one more thing about this metaphor is that you also probably realize that there's a little bit of gender in this metaphor, right? I want to now specifically call on the male part of the audience. Imagine yourself doing knitting. Just think about doing knitting. This probably feels a bit weird to you, right? This is not a thing that you're probably very comfortable with, like, oh, I could knit a sweater, and you know this is a thing you can do. Probably no one will judge you for it, but still, you know, it feels a little bit weird to think of you performing this activity that in many cultures is seen as quite female. This is also an angle of programming where there's so many people, specifically, of course, female people, that are like, I don't know if programming is something that I would feel comfortable with. How would people look at me if I would do this? And that is also where you see that stereotypes is not just something that is done to you. People absorb these stereotypes and think, no, I'm not a person who does programming. Like many men in the audience would be like, no, I am not a person that would make their own clothes and then wear them. You know, people would think I look very weird. So that is also very much part of teaching people programming, is that they think, oh, I didn't think I was the kind of person that could do this, and now I think I am the kind of person that could do this, even before they have learned many things. So this is really the path. We don't want to talk about bringing people that know that they want to learn programming into programming. We want to bring people that don't know at all what programming is and that might not feel comfortable about doing programming into a place where they're like, oh, I think I could learn this. Now I know what the value is. I want to learn more of it. Here is really where the interesting part of teaching programming lies. And this, again, is not something we can do with GPT. You cannot tell someone that has never done programming, oh, it's easy, you just go to this magical machine and you type what you want and then it does it for you, because I don't even know what I want. I don't know what the thing can do, so how can I even verbalize what I want it to do? So with that, I hope I have convinced you now that really everyone needs a little bit of programming skills so that they can participate in the world of software and that they can reflect on the world of software and change it if they want to. Also, maybe especially so in times of GPT. So I didn't just say this, I actually also am a person of action. So about 10 years ago, I started to teach in a middle school, so 12-year-olds, because I wanted to teach programming to them. I thought, okay, no one is doing this, I just go to the school, I will teach the kids. And I thought this is going to be easy because I thought, you know, these are 12-year-olds. I literally wrote a book on programming. How hard can it be? They just ask me some questions and then I know the answers because I know programming. And I give them the answers and then they will be impressed with my wisdom and they will learn and everything will be great. Right? This shows that I didn't at that point have a lot of experience in teaching. And what happened at that point is subconsciously I started to reflect on how did I learn programming when I was their age? So this is me behind my dad's real big computer in the 90s learning programming. But then I didn't learn programming from a person. I didn't go to a programming club or programming lessons because there were no adults in my neighborhood that knew programming. So how did I learn programming? I actually learned programming from a book. So for the young people, this is like the internet on paper. You could go to a library, a building with many of those internet on papery things. You would go there and you could take it home for 3 weeks. It was magic. And this book didn't really say, oh, welcome to programming class. This is a variable and this is a loop. No, if you would open the book, this would be shown. This is just a printed out code listing that you would manually type into the computer. And for the young people, hey, wasn't there a download link? No. Wasn't there a CD-ROM? No. All these things weren't there. You just manually copied everything into the computer. And this was also in English. And as you can probably hear, English is not my first language. So it's like typing these words, it says velocity. No clue, right? Just typing, practicing. And if you would make a mistake, then the computer would be super helpful, syntax error, or it would say expected comma or semicolon or end of statement. No clue what this means. But then if you're really determined, and also if there's no Netflix or TikTok or Xbox, then you really want to get your games and you have to get them from this book. So eventually, this is a way that I learned programming. And by some nodding heads in the audience, I think there were a lot of people my age, children of the 80s, that also learned programming that way. So the nice thing about, now I've been somewhat critical about GPT, but the nice thing about these algorithms is that you can actually extract the bias from the algorithms and show how a whole field thinks about learning to program. So if you ask it, show me a hacker before they started doing anything, you will get this. Which is a great reflection of everything that I've said, right? This is how so many people my age learn programming, that this is now in the machines. Like this is someone in their bedroom, on the computer. This is not someone in a classroom, right? So the view that we have of programming education is people alone at home. Also in a sort of a big room, in a wealthy household, from the looks of it. But it isn't a programming lesson. So this is our collective image of learning to program that very much fits my personal history. Well, you just sit by the computer and, well, this dude had CD-ROMs. I didn't have those, but otherwise it's sort of my experience. And because we have this experience, we have somewhat been mentally damaged. I'm sorry to report. Because we have internalized this idea that compilers are great teachers. Because it was the only teacher we had, right? We didn't do some sort of A/B test. We're like, oh, look, I only look at syntax error all day, or I have an experienced expert explain me things. No, this is the only thing we had. So we think compilers are actually great teachers because it was just the only teacher that we had access to in those days. And this was very much also how I started to teach. Subconsciously again. I went to the programming club, I gave the kids worksheets, like this exactly tells you what to do, you do it. If there's a mistake, the computer will tell you. I will be sitting in the back, drinking coffee, feeling really good about my service to society. Look at me teaching middle schoolers. I'm the best, right? Just to give you a little bit of context about the programming lessons that I was giving. Initially, we used a programming language called Scratch. Who has heard of Scratch? Yeah, many people. So Scratch is a block-based visual language. It looks a little bit like Lego code that you can click together. And then with this, kids could relatively easily make some things that they were gaining confidence, like, oh, programming, yes, look at me, I'm making things. But then after a while, as the kids aged in the programming class, they said, nah, this is a toy, teacher. This is not a real programming language. They see that programming, if they do something like inspect element in the browser, programming is text. You know, that's where the real deal is. And also many kids, the school where I teach is sort of an inner city area where kids are really motivated to learn programming because it's good for their career. Like they can be rich and work at Google or Amazon. And then you look at this, and it just doesn't look like a thing that's gonna make you the big bucks. It's clear that this isn't a real thing. And at this age, if there were like 12 or 13-year-olds, and what they want to be is an adult, right? They want to have a beard and a deep voice and a real programming language with letters. So I said, don't worry, children, we're going to do Python. Python is a super easy to use, friendly language that you can all easily learn. Look, this is Python. So we're going to start with the first lesson. You type print, and then brackets, and then quotation marks. And then, teacher, what do we have then? Is this like making Minecraft? No, it prints text on the screen. It was very excited for me when I was that age, but I'm like mildly disappointed already by the power of these adult tools. But that wasn't the worst of it. Sometimes, of course, they would make a little mistake, like typing an uppercase P. It's a very sensible mistake because sentences start with an uppercase letter in many languages. So this makes sense. Does the computer know how to do this? Of course not. It says name error, name print is not defined. How is name print not defined? I just used it two minutes ago. Right, so how can a computer be smart and quickly calculate 14 times 371 and also do not understand that a P is also a P? This is very confusing. Here's another one. It's very, very clear to us humans what this kid is trying to do. They just forgot the closing bracket, right? A computer should be able to just execute this because it's so clear what is going on. But it doesn't. It actually says syntax error, unexpected EOF while parsing. Teacher, what is parsing? I'm like, don't worry, child, I have the Dragon book right here. Like, I don't want to talk about parsing. Like, I want to talk about parsing all the time, but not to a 12-year-old in their first programming lesson, right? So these concepts jump into your classroom without you being able to block them off. Here's another one. Teacher, I have learned from my previous mistakes. Everything is there. The brackets, the quotes, print is spelled impeccably. I swear there is not a mistake in this program. Oh, but there is. There is a mistake. Should the computer be able to execute this? Yes. Does the computer execute this? Of course not. Indentation error, unexpected indent. Teacher, what is an indent? Right. So you cannot block these concepts off. And kids were struggling so hard, which I really found surprising based on my own experience. Like, well, this isn't so hard. I just spent 5 years every 3 minutes practicing this. So how can you not learn this in a few hours? And there were so many kids after the first year that said, this is stupid, right? I don't want to do program. If this is what programming is, like, I don't want to do it. I will leave. There were really only a few people that stuck in the programming class, and they were mainly boys, mainly kids that had programming experience before, either at home or in another programming club, so they had already some resilience. And also they had a clear idea of what programming was and where they wanted to go. So they had really gained a lot of stamina. And I think this was an interesting perspective for me to reflect on, again, gender in programming, because I thought if I go there as a female teacher, then girls will be excited because I will be a role model and it's good. The only thing they just need is a role model. They see that girls can do programming and then they will also do programming. But what I figured out is we talk about like role models and we talk about explicit stereotypes, but we never really talk about programming language design connection to gender. But imagine if you're a girl and you come into programming class already with a very low confidence in your own ability. You think programming is hard and this is not for girls. And not because you think this, but because society has told you this. I have had girls that were brought into the programming lessons by their dad, and then the dad would just literally say, yeah, I'm not sure if this is for her. I mean, I guess it's more for boys, but you know, maybe let's give it a go. Maybe she will like it. Don't say these things. Girls are so exposed to all these stereotypes that programming is hard and it's not for them. And imagine that's your vibe coming into the lesson, and then the first thing you get is unexpected EOF while parsing. Then you'll be like, they were right. this is not for me, right? It's so much valid, the unreasonableness of parsers just validate their prior feelings about themselves, and then they're like, I'm out, right? It's very hard. And of course, if you want to do this, if you feel like a person that could do it, way more likely to be a boy, then you're like, oh, this is an interesting challenge. So I really figured out that the design of this programming language also really impacts who feels welcome. So at that point, I got really interested in how do people learn anything? Right? Because these 12-year-olds in my school, they knew so they knew writing, they knew math, so clearly their brains were fine. How come I didn't also manage to teach them programming? Why was this so hard? So I started to read a lot about learning, about cognitive science, so much that my actual career working at the university was suffering a bit from me only reading and not really producing any new ideas or software. But I really, really wanted to know, how do I get the programming into their brains? It must be possible. And luckily, I was helped by people from the psychology department that helped me really understand what to learn and where to look. And ultimately, there were some things I found out. One of the things that I learned about learning is if we teach other things, for example, learning to read or write, then we do this in very, very small steps. If you have a 5 or a 6-year-old and they're writing this, you're not going to say to them, syntax error, unexpected floating I, right? That's not what you're going to say. You're going to say, well done, buddy. Some of these things are letters. Keep going. So you're not going to be super strict at that first level. How discouraging would it be if you'd say backwards and no, stop. This is not even a word. No, of course not. You do that very, very slowly. First, it's just letters. And then it's very simple sentences. Cat in tree. That isn't even a sentence. No, but it's great. Keep going. And then slowly we add complexity to the language. We add punctuation and articles and verbs. That doesn't go at once. So then I thought, this is actually a brilliant idea. Teaching things in very, very small steps with slowly changing rules. This could be done for programming. And I happen to have a PhD in software engineering. I know how to make a programming language. I think later on, if they're going to make a Hollywood movie about me, this is going to be the montage. Like, pom, pom, pom. I trained for this. Pom, 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 pom. I can do this. So I thought, I am going to make a programming language that works like this. Just these very small steps that build up to an actual programming language. So that's what became the Hedy programming language. So this is Hedy. You can see that it runs in the browser because many teachers can't install anything in schools. So you just print whatever you want, hello, YOW, for example, and you run it, and it just runs. No brackets, no quotes, nothing. This just works. And what I also said is that just text on a screen is very boring. And it very often takes a long time to make something that's a little bit interactive, that shows the value of programming. So we, from the first level, also add user interaction. So we can use ask as a keyword that will ask you a question, and then it will repeat the answer back to you. So you can say, how are you? And you type great, and then you run the code, and it says, ha, so you are great. So immediately we're showing, look, a program is something you make with a user in mind. Someone is going to use your program that's going to type their name, and then you will say hello to them. Showing, look, this is where programming could go. And then slowly, every level, we add a new concept. For example, here's level 2, and in level 2, we add the concept of variables. So here we assign the value Felienne to the variable name, and then we print hello name. And this actually just works. So now you're like, what? But no, stop. This one is a variable, and the other one is plain text. Why is this working, right? It's a very confusing program for us experts. But for a beginner, this is actually very, very nice, because they can fully concentrate on the concepts of a variable. They don't have to think about syntax. Just to compare this with, this is the Python you would have to type if you want to do the same, get the same effect. So then you have to think about quotes and brackets, and there's so many things you have to think about. Whereas in Hedy, you're just thinking about the variable. You're not thinking about syntax. We just push that idea to later in the trajectory. So here's level 4, and in level 4, we add quotation marks. So after they've gotten a little bit of practice with just input and output and variables, we're like, okay, new rule. From now on, you have to add quotes if you want to print text. Okay, this is working. And then if you make a small mistake like this one, you'll get an error message that's actually readable. It says, be careful if you ask or print something. It should be enclosed in quotes, and you forgot that for the text. How are you? So because the language is small, we can give error messages that are very precise and very actionable. It tells you what's wrong, and it tells you what to do in a sentence that you can process. This is level 18. So gradually we add loops and conditions and functions. And then at the end of Hedy, level 18, you're actually doing a valid subset of Python. So we slowly bring you to a real grown-up language that is Python. It's very much like trainer wheels on a bike, right? You have trainer wheels on the bike, and then after a while you can do it. You take off the trainer wheels, and then you have a bike. So it's not like you have to learn this extra thing that doesn't have value. It's that this extra thing ultimately becomes the real Python programming language that people use in practice. And this just runs in the browser, still in our platform, and then from here, they can, if they want to, go to other platforms that run Python. So here I just casually said, oh, I made a programming language, but how do you actually make a programming language? I started to realize when I talked about this topic that there are quite some programmers that have never made a programming language, so they might only have a passing knowledge of how a programming language works on the inside. Again, here we can use a metaphor of text. If you have text, then first you have to spell the text, and then if you've spelled the text, you can actually understand the meaning. We adults, we can do this at once, but for a child, these are two distinct steps where you go like, cat, and then you're like, cat, oh, I know what a cat is. Oh, foot, I know what a foot is. This is a cat at a foot. These two steps are also exactly present in most programming language systems. First, you have to spell out the words, and then you do the meaning. And the spelling we very often call the syntax. For example, this is a Hedy program, and the syntax of that says, first you have print, followed by letters, or you can also have turn, the keyword turn, for the turtle, followed by digits. And if the parser is going to process this language, it does that letter by letter, following the grammar. So it will go like, a P, correct, R, O, I, O, N, T, perfect. Now what I'm expecting is only letters. These are only letters, correct. Next rule, turn, T, U, R, N, perfect. Now what I'm expecting is only digits. Correct, this works. So that is how a programming system processes a programming language. Yes, correct. Now here you have another program, quite reasonable, where in the turn, the kid has typed 10 rather than the number 10. So here it goes wrong. The first line is fine, but then in the second line, you have turn, and then what it's expecting is digits, but what it's getting is letters. And then you get an error message, incorrect, T is a digit. If you know this, you also better understand error messages that you're getting in programming languages, like the syntax error unexpected EOL. It was doing, oh, I see an end of line, but I didn't expect it, so it says unexpected end of line, because it's really doing it letter by letter, like a 5-year-old does reading. Then the other part is the meaning, expressing, once you have processed the program, what it means. And this is what we often call semantics. And what you can do, if you want to, is change that semantics into something in between, like a description. Print means printing all the letters, and turning means turning digit number of degrees. And then turning that into bytecode directly, or the zeros and ones in the computer. There are a lot of programming systems that work that way, that they directly process the source code into bytecode. But we don't do this. We actually turn the Hedy code into Python, because it's already quite close to Python. So we do a process called transpilation, where we take Hedy, we turn it into Python, and then we run the Python that is outputted by our transpiler. There's a lot of software that you can use to author these type of systems, parser frameworks, or language toolkits, programming languages workbenches to create a programming language. However, they're often exactly created for one syntax, because you have one programming language, like one C or one Java. Maybe sometimes they support two different versions or dialects of a programming language. But certainly those programming systems aren't made for 18 different syntaxes with 18 different semantics and 18 different steps towards Python. So we had to do a lot of programming magic to actually get this to work on top of platforms that weren't really created for a set of languages and that then processes a set of different outputs. So this is very much the interesting part of the field where I'm in, where I'm really working on two sides of programming. On the one hand side, I'm building programming languages, but it's very much the computer science-y side of things, and this is where I'm sort of supposed to be with my PhD in software engineering. I should build systems. But then I'm also so interested in the other side, looking at people, looking at kids, engaging with people that are using my tools. And this is where some computer scientists get confused, that you like both of these things. Like, oh no, this is confusing. Like, people will ask me really like, are you in computer science? Because you interview children. This is very confusing that those both sides are necessary and that some people are really interested in the both sides. So after I had built the first prototype, I went back to my school. I said, kids, I have built something. Let's try programming with this new system. Let's do Hedy and see if with this system you'll actually enjoy programming more and less kids will drop out of my programming class. And what we saw in the first experiments is that when we were doing Python, every classroom would be chaos. Right? So there's like 30 12-year-olds in the classroom. They're all programming and they're all getting syntax errors. Teacher, I have an error. And I have to run around, look at all the errors. And it's actually quite hard, even if you know programming, to make snap judgments on programming all the time. Oh, wait, maybe you have too many brackets. Let me see where the mistake is, because they make big and contrived and complicated things. Maybe there's an indentation error, look at the spaces. It would take me a lot of energy to run around because I couldn't let them at the computer alone with something like unexpected indent. They really couldn't advance without me. In the Hedy situation, there was really this sort of sea of calm in the classroom, insofar that's possible with 13, 12-year-olds, that yes, they could do it alone. I would give them a few programs and then some would have an error, but then still we would look at the error together. I would say, there's an error in line 4. And I could just confidently walk away. I didn't have to explain more to them because they could read the error message and proceed alone. I could tell them with confidence, saying, just read the error message again. I'm pretty sure it exactly says what's wrong and what you should do. And I could go to the next one. So from spending a few minutes at each kid, I really went to spending maybe a few seconds, and they could really advance alone. So as a teacher, it was so much more relaxed in the new system. And then I thought, yes, this is going somewhere. This is going the right way. I also asked the kids directly, what can I do to make Hedy even better? And then one kid said, I think you should improve your error messages. So I said, really? Have you seen Python? Have you seen C++? I think we're doing well. It's like, show me a program with a problem. He said, this one, teacher, this error message is terrible. So I was like, now, this is what it says. There's a mistake on line 1, position 12. This is exactly where the mistake is. And there shouldn't be a comma there because this confuses the parser. This is a perfect error message that exactly explains what is there. Read to me this error message, because I think this child just hasn't read the error message, right? They're just lazy, they don't pay attention. Read the error message to me. So the kid goes, yeah, there's a problem somewhere. You typed, but that is not allowed. Like, what, sorry? Because like, why can't I do typing? You typed, but that is not allowed. Why can't I do typing? I do typing all the time. And it makes so much sense, because what have we told 12-year-olds for 6 years? If you see a comma, you take a little pause. You typed, but that is not allowed. And this is such a great example of why you have to sit down next to users. I could have easily seen in the database that this wasn't a great error message just because kids wouldn't advance after it. But not until I sat next to a kid that vocalized to me why this was confusing. I would have never been able to come up with understanding why you could interpret it like this, because for me it is so clear what is going on here. So we actually made a change to the error messages that characters now are outputted as words. So instead of the symbol comma, you just get a comma or a quotation mark or a question mark. And now it turns this into a sentence. And that really, really makes a difference. So there's really these small things that you can do to not drive your users crazy are really, really important. What we also saw specifically with other teachers in my school that were also using Hedy is that the teachers were very much struggling with coming up with good plans for programming. The kids would say, "Teacher, what should I make?" Right? And then the teacher realized that they didn't really know what assignments to give them. And I realized also that I could come up with these things sort of on the fly. I'd say, oh, you make a heart or you make a story about a princess. I could help them. But that information, those ideas I had about programs weren't really in the system. So teachers that were using it were really struggling to use it properly, to feed ideas into the kids. The kids were all the time like, what should we build? And teachers didn't really know what the possibilities were. And this too, I figured out, has very much a gender difference. Because typically, boys really like trying out stuff. Boys learn better by tinkering, by exploring, by trying, where girls learn a lot better by getting detailed assignments, expectations outlined really well, so that it's clear what they have to do, and then they will do it. And this modalities of learning are quite well documented in research, where in general, not everyone of course, in general, boys and men like trying, and women and girls like getting instructions. So something like, oh, we don't need to write documentation because no one reads documentation is actually already quite a gendered statement, because men don't read documentation, women actually like to read documentation. That's weird, right? And if you know that those different modalities of learning are different for different genders, then you look at programming systems and then you see who they're for. Who is this for? Someone that likes to dive right in. This isn't for a person that wants to read what the goal is, because there's no explanation here. Even a programming system like Scratch, that's one of the most used programming languages for education, doesn't tell you where to start. It has this one pop-up saying, oh, here are some ideas, and then you're on your own. Everything is there. You have access to like 150 different blocks. What do I do? Well, whatever you want. But I don't know what I want. Right? And then that modality really isn't present in programming systems. So we added that later in the trajectory. We have all these things that we call adventures in Hedy, where there's a built-in explanation that tells you what to do. Here, exercise. This is what you do. And then now also the modality of learning where you do want to start with an explanation is supported. And you don't have to do it. There's even an option in the UI to disable all the explanations. But if you want to do explanations, if you're the type of child that really benefits from first knowing what is expected of them, it is possible. And this also, again, goes down to this model, right? That if you don't know what programming is, you don't know what you want. A question like, what do I want? And an answer like, whatever you want is what you can build, doesn't make sense if you don't know what you want to build. You really need to have these first steps laid out to you. This part is where explanation matters most. This is, I would say, where teaching happens. You can't turn someone that doesn't know what they're going to do into someone that knows what they want to do simply by exploration. You have to have a teacher that tells you this is what you're going to do. Like if one of you after this talk is very interested in starting knitting, then you can go on YouTube and find many videos. Like everything is explained to you there, but where do you even start? What tools do you buy? What yarn do you need? You need someone to tell you where to get started. And this second part is way more where, let's say, learning happens. If you already know what you want to do, you can do a lot on your own. There's a lot that you can do, then tutorials make sense and explanations. So that is where learning is. And what I figured out after doing this for a while is that tools for teaching are really, really different from tools for learning. A tool that allows me as a teacher in a classroom setting to teach 30 kids is different from a tool that's made for kids to explore programming on their own. And because so many people in our community, in the programming community, have this self-taught history that I also had, is that we tend to think of tools of learning. We don't even consider that there's also people that need this help. And the problem is that tools for teaching really help this first group that doesn't know something. But most of the tools we have, because of the history of our community, are tools for learning. And what I figured out is if you have tools for learning in a classroom where there are a few kids that already know a lot, then they will benefit, but the other people will stay behind. Like when we used to do Scratch initially, some kids would really go and others were just stuck, right? The beginners would say, okay, teacher, I put one block on the screen. Now what do I do? Right? They really didn't know how to advance. And this system didn't let me help them in any way. Whereas in the meantime, these guys were like, teacher, I made this. Now I want the palm tree to be blue instead of green. Can you help me do that? Like in one classroom. And as a teacher, it's so hard to manage this type of differences that I want to spend a lot of time with the beginners. But the kids that already know more, they have very detailed questions and also they have enthusiasm, right? They would be, for me, I would be their favorite teacher. So they would be, oh, no, I love programming, look what I made. And especially when I was an early teacher, I thought, oh, this is so cool. Look at what this kid can already do. I will help them grow. But then after a while, I thought, this kid doesn't need me. This is not the kid that needs me to go further. They already know so many things, probably maybe at home or from YouTube. That's not where the problem lies. The problem lies with those other kids. But tools for learning don't really help you with that. So after I figured that out very, very, very slowly, we added more features to Hedy to actually help teachers manage differences in the classroom. So if you want to, as a teacher, you don't have to use all these adventures that I showed you before. You can actually customize your classroom where you say, well, we're just beginners. We're just going to do these few assignments. And you can even upload your own lesson plans into our system. So you're like, oh, it's December and the kids are really excited about Santa Claus. I will give an assignment to them so they will do something with Santa Claus. So you can add meaning into the classroom. And if you want to, as a teacher, you can close off levels. So you can just say, only level 1 is open. You cannot go to other levels because they're currently locked. And this helps me as a teacher to get everyone together. If you already know many things, oh, you're already at level 7, you go do something else. You do your German homework or your history homework. I first want to make sure that everyone sets their first steps. And then together as a group, we will move on. And that is what a tool for teaching does. It helps you actually manage a classroom because that's what you have to do if you have 30 kids, right? If you just have the one, then maybe they can do whatever they want. But if you have 30, then you have to make very conscious decisions of where is my energy going. And if you don't make these decisions very consciously, it's very likely that your attention will be drawn to the kids that already know a lot, and then maybe that's not the kids you really want to help. So then after a while I said, okay, children, I have improved the error messages. What else do you want? Well, we would like to program in Dutch. So I was like, why? And the kids were like, why not? You made this? Everything was already in Dutch, right? So the UI was in Dutch and the error messages were in Dutch. It was just the programming keywords that were in English. They were like, why? Why did you make that in English? Why don't you make that in Dutch? We speak Dutch, everything is Dutch. Why not? It's like, well, because it's a lot of work. I don't feel like doing that. That's the reason. But I also started to reflect, like why are programming languages in English? So one reason that programming languages are in English is that programming languages are in English. So there's this natural filter for people that know English into programming, and all the other people aren't in programming, so they're also not complaining about programming languages not being English, at least not to the people that have some power. And another reason that people worry about programming languages being in English is that if people program in different languages, then they cannot really understand each other. If someone's programming in Turkish and someone else is programming in Swedish, and they won't be able to communicate with each other. So those are reasons that programming languages aren't usually in English. But it was the pandemic, so I didn't have a lot on my hands. So I thought, okay, I'll build a small prototype to actually turn the keywords from English into Dutch. And now that you know a bit about how a programming language works, you figure out that's really not so very hard. You just take turn, and then you delete it, and you add draai, which is turn in Dutch. And then you're done. You just swap out the keywords for localized keywords, and then this works. So once we added this to Hedy, which is open source and on GitHub, once we added the option for 2 languages, stuff blew up. People were like, oh my God, this is so cool. And they added German and French and Spanish and Portuguese, and people started to add languages. And I thought, wow, this is great. I'm so proud of myself. I made a programming language that is multilingual. Look at me. This is dangerous. Do not be proud of your achievements. Never. Do not sit down and think, yes, this is done. Because I have a friend, and he's from Palestine. So he said, so Hermans, very impressive. These Latin languages going from left to right. Well done. Now do Arabic. Man, no, I don't want to. That really sounds like a lot of work. But then, of course, I started to think about it. Like, imagine being a teacher in Egypt or Palestine saying, welcome to programming class. The first thing we're learning is print. It starts with a P. And the kids would be like, what is a P? And how is a P different from a B and a D? Like, that's hard, right? That threshold is actually quite high. And again, why? Why isn't it also in other natural languages? So my perspective, after reflecting on this, I said, okay, Aladdin, I understand that it would be easier to learn if we swap out the keywords. And he said something very, very valuable. He said, yes, it is easier to learn, but it's also very much about easier to use. But why, right? And he explained to me that if you have a laptop or a computer, then it can only be set to one language keyboard at once. So either you're typing English letters or you're typing Arabic language. So if you're printing code, then probably you're outputting your own natural language. But if the keywords are in English, you have to swap keyboards. So you have to do print, and then click with your mouse or press a button, go to the Arabic keyword, and then type the Arabic string, which is just one extra action every line. And if your code is a little bit more complex, like if you have an if statement with Arabic variable names, which is quite even supported in a lot of programming languages that aren't Hedy, then you have to swap all the time. Like if in English, go to Arabic, type the variable name. Go to English, type the keyword. Every line you have to switch multiple times. And that is just very annoying. That's not so much a problem of inclusion as it is a problem of ergonomics. It's just so annoying to switch keyboards all the time. So I thought, this is such a good perspective. This is something I have never thought about as someone whose language uses the Latin alphabet. If you can do this on one single keyboard, it's just gonna make you so much more productive, which so many people care about. And this, I think, is maybe the best argument in favor of localized programming languages, is your variable names and your strings are going to be localized. If you create a program in, I don't know, Polish, then your UI is in Polish, or you're going to output Polish strings. So it's just annoying if you have to switch keyboards so that you have access to the O with dots or the L with a stripe in it. That will not be easily accessible from an English language keyboard. So it's like, yes, Arabic letters. We put this just in the grammar. It's not very much harder than doing Dutch. You just take a keyword, turn, and you turn it into estradiol, and then it just works, right? This is not hard. Look, this is Hedy. I put the keywords there, and you can make a drawing in Arabic with the turtle. Look at me. This is working. Dangerous moment. I was feeling good about myself. I thought, look, all the keywords are in Arabic. Yes, this is working. And now my friend is like, yeah, but can we also do Arabic numerals? I was like, what? These are Arabic numerals. It's like, no. These are Arabic numerals. I was like, what? Sorry, what? I didn't know this. I was on this planet for like 35 years, not knowing that Arabic numerals are not Arabic numerals as we call them. And it's really weird because in my country, in the Netherlands, if every 12-year-old by law has to know Roman numerals. This is in our mandatory curriculum. So all kids know Roman numerals so they can converse with clocks and buildings. It's very important. But then 300 million people actually use these numerals, and never did I hear about it in elementary school or in university, where I took like 5 compiler courses because it was my favorite topic. None of those courses actually ever mentioned that digits isn't just 0 to 9, but there's dozens of different numeral systems. No course ever mentioned this. I had to be ignorant for a very long time, right? And then it's really not just about me being ignorant, it's also just about this whole system of education never teaching you about quite relevant things, to be honest. And when I dove into this, I actually got very sad and angry. After it was a roller coaster of emotion. First I didn't know, and then I knew, and then I was like, oh no, my eyes have been opened. Because if you go to Python and you just take 2 and 9 and you add it, this works. But then if you do 2 and 9 in Arabic numerals, it doesn't work. It fails in a horrible way. It says invalid character. Your numbers that you've used for your entire life are invalid characters. Like, who is Python to decide what numbers are numbers? And this isn't just a mistake. There's this British philosopher called Miranda Fricker, and she has reflected a lot on whose knowledge matters, whose knowledge goes into the knowledge base of humanity. And if you say programming languages are capturing the knowledge of humanity, which some people are saying nowadays, then who is included, right? And she calls something like this epistemic injustice. Epistemic is the knowledge of knowledge. And if some people aren't involved in knowledge creation, then they're going to be left out. And first I thought, maybe this is just Python. Maybe Python doesn't do Arabic numerals. So I actually checked the whole TIOBE top 10, just the simplest thing, adding 2 Arabic numerals. Here we go. This is C. This is C++. You get not 1 error, but 2. Great. This is Java. This is C#. This is JavaScript. This is Visual Basic. PHP. PHP is nice because it offers to convert the numeral to a string and then still fails. Thank you. This is SQL. I had high hopes for SQL. I thought, SQL is quite a friendly language. Databases are probably used to different text and different numeral systems. No, still fails. This is assembly. It's not so easy to create a program in assembly for demonstration purposes to add 2 numbers together, but once you're done, it still doesn't work. So no one gets this right. And it is so simple. It doesn't cost you anything to add these numerals because these symbols aren't really used anywhere else in programming because no one has heard of these symbols. So clearly they're not used in your grammar. So it's so easy to do this, but no one does it because just no one thinks of it. It's very much like you all not making your own clothes. It's not that they said, oh, should we also support Arabic numerals? No, it will be complicated because of reasons. It's just they didn't even think of supporting this. I also didn't think of this a while back. So Hedy, of course, does this. You can simply add 2 numbers, and then it will actually output like you would expect. And you can also use it in a loop. If you have a loop iterator, then you can iterate. This is like a for statement for I in range. And you get an output also in Arabic numerals. This is nice. This works really well. So I was now proud of myself, and no one disturbed me. So that was the high point. Like, this was working. So from this tiny, tiny prototype that I built 4 years ago, just only to use in my own classroom to help my own students learn, Hedy became this massive open source project. In my previous talk that I did in Melbourne, I said we supported 48 different languages, but now we support 49 because someone added Maori in between my talks while I was here. So that's super cool. So we support 49 different languages, multiple right-to-left languages, multiple non-Latin languages, and we have about 400,000 users every month. So that got out of hand a little bit. So much out of hand that I'm now also talking about this part of localization. So I just wrote a paper a month ago about 12 different features of natural languages that aren't well supported in programming languages, like numerals and keywords, but there's so many things that programming languages don't support well. So if you are involved in building a programming language and you're interested to see what you could add, then maybe you want to check out my recent work on this. So before we go to coffee, I want to reflect on the future, right? I want to see where are we going with this field. But before you can look at the future, you also very much also have to look at the past. So if you look at the past of technology, you see that there's always really been an issue with who has access to technology. If we go once more to the metaphor of writing, then who did writing early in the beginning of writing? In many cultures, in our Western culture, this was religious people. Those had access to writing, and you could see that by the stuff that was being written at the time, which was the Bible, basically. That is what they would write and copy all the time. And then after a while, more people got reading skills, but it was mainly the elite. And you can see that by the type of things that were written about in those days. And then now, everyone more or less can write. And if you can write whatever you want. You can write like a love letter or an angry letter against polluting industry. You can really do what you want with this power of writing. No one can take that power from you once you have it, which is pretty amazing. Now let's look at programming. In the early days of programming, not a lot of people could do programming, mainly physicists. And it showed by the type of problems that were being solved in the early days of programming, which were math and physics problems. Then a little bit later, more people could do programming, but they were mainly the elite, mainly rich white boys from affluent families and countries could do programming. And it shows by the type of problems that they were solving, like going on vacation cheap, getting your groceries delivered to your house, and taking a taxi without speaking to people. This is their problems that have been solved really well, but this isn't everyone's problem, right? So we are sort of here where more and more people are learning to program, and I'm really looking forward to this world where so many people can do programming, right? I'm so curious what everyone will build, that instead of writing a love letter, maybe someone will make an app for their husband, to express their love, or instead of a letter against industry, maybe they will do data analysis against the polluting industry. Look how polluting you are. I actually have some numbers to back this up. So it's really cool that we will have this world in which everyone can do a little bit of programming. But I'm also a bit worried about this world, because so far, programming hasn't had a great track record in diversity, right? If you look at the stack of software that we have built, why are voice assistants always having a female voice, while at the same time performing worse if women speak to them? Why, right? That's interesting. Who is on Strava? Friend me and check out my 3-hour 57 marathon I did last year. But also, Strava is an app, for those who are not on it, an app where you can track your workouts, and also you can track your equipment. So with a workout, you could say, I used those shoes, or I used that bike, so you can see how much wearage that your equipment has. In Strava, you can track no less than 35 different bike parts, like pedals and a saddle and a wheel and whatever. However, you cannot track what bra you were using. I want to know if I ran, like how much miles have I ran with this before I buy new ones, like I do with shoes, and it doesn't allow me to track my bra. Why? It's like half of your user base is probably wearing a bra while exercising. Why is it not on there? And it's not that they don't know. I've pointed this out on Twitter repeatedly, and they haven't really changed anything. And then even more serious, like Airbnb and Uber. Whose neighborhoods are affected by Airbnb and Uber? And whose livelihood is affected by those apps? Like, there's so many apps and programs that take these perspectives. And then I'm not even talking about gender bias in GPT or face detection algorithms having racism problems. There's so much software that is so biased. And then you can think, why is that? Like, and one reason is because the world is biased. The world is racist and sexist. So clearly that exists in the programming. But this tower of software that we have built also leans on programming languages. And then if you look at who was involved in the creation of most programming languages, this is the TIOBE top 20. Out of those, 18 are solely designed by white men. only 2 are made by, or partly by, men of color. And in no of the whole top TIOB 20 were women involved in the initial creation of the programming languages. So we are half of the planet, and we don't get to participate not only in building the software, but also in building the software that builds the software. And once you see that, you can also sort of not unsee it, right? If you look at something like C++, then Miranda Fricker, if she would know C++, she would say, this too is epistemic injustice. Whose lived experiences are in this program? Certainly not the ones of non-Western people, because you have to write a 0 to return, not a suffer in Arabic, for example. But also women, who probably by the time they're 18 and learning C++ in university, for 10 years have been told that programming is hard and not for them. If you know that that's the experience of so many people, then certainly you wouldn't build a programming language like this, because this is definitely driving the point home that programming is hard. And also another perspective that I didn't get time to talk about this much is people with different abilities, different ways of reading source code. Imagine that you're blind and that you're using a screen reader to consume C++. It would go like ctd : cout, smaller, quote, hello world, quote, semicolon. That's a lot of work for just printing something. So this perspective of how would my code sound if I would use a screen reader is probably also not something that many people have considered. So all these different experiences from different people aren't even present in the programming language. And we're just not catering to everyone. And then, of course, this really goes on in the rest of the whole technology stack. But to close this on a little bit of a high note, right? Let's not be too bleak about it. It's not just about accommodating all those different people in our programming language design. It's also just making programming languages that are more exciting and cool. There's really so many programming language ideas now that we're missing out on because we've only looked at making them Englishy or English-based. Like one example from Arabic is, in Arabic culture, people really don't depict humans or animals. That's just not a thing that's present in art a lot. What is present is geometry and letters. So this is Alhambra Mosque in the south of Spain. And if you don't read Arabic, then probably you don't notice, but these are actually letters. And these are also letters. And these are also letters. So they just have a different relationship with letters. Letters are a work of art, of calligraphy, of beauty. And that shows in the type of concepts that they support in their natural languages. So this is a little bit of Arabic, and the part in red, you see that it is prolonged. So they have a character where if you connect letters together, you can prolong the character so that it nicely lines out. This is called the tatouil character, which is a little bit like an underscore if you see it in code. This is such a nice concept, so that your lines will always be laid out nicely. And this is a thing programmers like, things to be laid out nicely. So this is a little bit of Hedy in Arabic, and this is regular keywords, and you see that sometimes the keywords are also connected to each other. So I wanted to support this tatouil also so that people could use it. And of course, this again wasn't my idea, right? This was the Arabic part of our community saying, well, kids are going to want to make it nice because this looks a little bit messy and they can use a tatouil to make it more beautiful. I said, okay, it is still the pandemic. We will add that to the programming language. That sounds really cool. And then you would think this would literally be one line of code, right? Something like exclude whitespace. Like exclude tatouil. This should be very easy to do. But of course, parser frameworks do not support this because they've never heard of a tatouil before. So this is actually my actual grammar, where we use a little bit of pre-processing to just put the tatouil in between any letters in the keywords. And then you also see, if you pay close attention, that it doesn't really lay out the regular expression well because it gets confused by the Arabic characters and then messes up the word order of things. But this actually worked. So my grammar now is horrible, but my code is beautiful. Let me show you, not this is possible in Hedy, but also this. And really, if the diversity angle and the inclusion angle didn't really convince you, like I'm okay with that, but this must convince any programmer. I want this now. I want Python to support print. Hello. how beautiful it is if you can modify your keywords so you're beautifully lined out. And this is really just scratching the surface of all the beautiful natural language concepts that we're missing out on by really just focusing on English language. And again, if you're really interested to learn more, if you want to read my recent paper where we have 12 of these different aspects that could be done in programming language design to make them more inclusive, but also just to make them more interesting. So if you're interested in joining and maybe adding one more language before I leave the country at the end of this week, you can simply go to hedy.org/join, where you can find all the information about translating, getting teachers on the platform, and also contributing as an open source contributor. Thank you so much.